None of those powdered potatoes.
Okay, I'll get started. So the conversation here today is about something we do all the time. When we're talking to customers, I tell them all the time, this is our bread and butter. This is what we do and what we're good at. And so we better be damn good at it, right? So the discussion today it's about something we all know, but it's about how to take it to the next level.
How can we get this on it?
You can log into the GoToMeeting. If you got the invite, you can pull it up. You didn't. Sam, can you send it or go in there and log in for him? How many people you got in there, Sean? We could squeeze.
Brad's in there and Joseph's here.
I'd rather them all be in here.
Right.
If you just got 3, let's get it. I can stand.
Who's not here?
Brad,
Can we scoot down that way a little bit?
Sean,
Where are they
Room
at?
for one more over here.
that room.
Joseph, just make it sit over here.
Oh, why I'm always getting crammed up next to Sam.
You sit by me every time.
Because you were sitting in my chair.
Pretty sure I have a few more meetings in here than you, so I'll probably get to claim this chair.
Yep.
Pretty sure I've been here a few more years than you, so,
That don't count.
yeah, but. Being for real?
Yeah.
It's a trap, don't do it, man. That's a bad seat, that's where you get struck from behind all the time.
Give you $1.
Give me a
I got another $1 right there.
Yeah,
Okay.
$1.
Donate that dollar.
What, Brad?
Split it with you, that's take one for the team.
If it knocks me out, I probably wouldn't remember it anyway, so we're okay.
So, gosh, that's the message here. We're a team. We're trying to do things together. And what's we mean?
More than one.
Yeah, the whole company. So it's not just about getting it done. I want you to understand what you do and where it goes and what it means, because there's a reason why you're doing it. It's critical, and if I tell you it's our bread and butter, what that means is that's how we make our money, and we better be damn good at it. So I don't know, catchy title, whatever. We're talking about disassembling and inspecting vertical turbine pumps.
Are recording?
Yeah, it was recording.
I think we're still recording.
So you get a little interview or a little opening from me, and then we'll dive into the form. That's really the subject matter here. Maybe. Okay, so you got to understand what you're doing, right? Why am I disassembling it? Who uses the information I record? And how do I log that information? So I got a caveat here. I did this once upon a time out in the shop. I wasn't very good at it, but I tore down a couple of them. It's more than 10 years ago, and I just did a couple. So don't have a whole lot of experience. Probably guys in this room know more than, or have done many more than I have, but I've got a knowledge of the backside of what you do that could be helpful. So that'll be a lot of our discussion today is what happens with that information I record. So Shane was talking about a habit a minute ago. What was the habit, Shane? I don't know. Thanks for participating. So we got things that are habits that we do all the time, right? Example here, the grocery cart. If for me, it's a seat belt. As soon as I turn the car on, it just instinctively, whether I'm, going 100 yards or going 10 miles, whatever, put the seatbelt on. And if I don't brush my teeth in the morning or before bed, probably turning around to go brush my teeth because I'll think about it the rest of the day and it just might as well go do it. And so by definition, habits are repeatable. Sam liked the joke about the toilet paper, right? You roll the roll inside out or outside in. That's debatable, but we all have our way. Or you're lazy and just did it. Okay. So ask yourself before you start knocking into it, what's the objective here? Why am I disassembling it? Anybody got any ideas on a turbine pump? What's common?
Low flow.
Off in production, right? What else?
Vibration. Locked up.
Maybe noise, vibration, some type of condition that the owner doesn't like, right? Any other reasons?
Routine maintenance.
Preventative maintenance, that's a common topic that we try and sell, Let's get into it before it gets unrepairable. Anything else? That pretty much covers most of it, I think. So everything comes to us with an intent. We don't just get pumps just to get them. Chances are they want us to look at them. They got a problem with it, vibration, noise, we call that harshness, or the production is dropped, flow rate, gallons per minute, whatever, that's decreased, or the last one there is the pump just won't run, locked up, broken shaft, who knows, maybe it turns and just doesn't make water. So our job, and I say our, like we talked about initially, Smith Pump's job is to address that need. That's why he's sending it to us. So keep that in mind as you look at this, as you look at the pump or think about the pump, what's the purpose? And if you don't know that, let's ask. There's nothing worse than knocking something all the way down and the guy says, oh, it just wouldn't seal. I just wanted you to go into the packing. Well, now you've just gone 8 steps past where you should have. And so we have to communicate that to you somehow. That's typically communicated in the traveler. Pump service form's a great place to log that. That's what that form's intended for, is to capture the reason for receipt. So understand that. Who uses the information I record? That's the next step. That's something I ask myself all the time. What's my audience? Whether I'm doing a quote, doing a report, reviewing a specification, who am I doing it to? Because I have to understand what they want from me. It doesn't do any value to tell the guy at Blooming Grove about all these detailed measurements. He doesn't care. He just wants, to know if it's repairable or not. So when I'm doing a quote, I keep that in mind. So the audience here, who do you think the audience is when you do a vertical turbine teardown? Your main audience is the project manager. And for what purpose? So understand what the PM's going to do with it, right? What's he do? He just look at it and he says, oh, great.
It's a blueprint for them to write a quote.
Exactly. He's going to turn it into a price. Maybe he's communicating what's wrong with the pump to the guy. If I've repaired my car 4 times in the past year, I'm going to start asking questions. Hey, why does this keep breaking? Why do I keep having to bring this to you? Quit just fixing it and solve the problem. So they're considering things like that all the time rather than just sending pricing. And that's what our competition does. They just send them a quote. We get a lot more details than that. So here's the audience. So you tear down the pump, you make the report. Project manager reviews the teardown report. He does an interpretation. He'll come back to you with questions all the time. That's what I'm talking about next level. Let's eliminate that step so that you just communicate it. He can use it and do what he needs to do with it. If we can eliminate back and forth, we can get more efficient. we can get more pumps out the door, make more money, right? That's our goal as a team. And so, project manager, after he rewrites a report, a shop inspection report, he'll give some conclusions, really focusing in on addressing the problem. If it's preventative maintenance, he'll tell them what maintenance. If it's failure, he'll tell them why it failed, ideally. Sometimes we just don't know. And then we recommend actions for repair. That's the scope. And from that scope, we can go send a price, right? So what I'm going to do, I've got a tool that I use as an old PM to help log the actions needed to create a quote. It's called a pricing worksheet. And so everybody gets one today because you have to understand what's going on the backside to understand what to do at the teardown. And then you also, there's your swag, Junior. You also get a Simplo pen. Now, I got a warning here because I've heard these explode. So,
Do they vape too, or what?
nah, I just wouldn't put it in a pocket of a good shirt. How about that?
So you're giving us junk pants.
I'm giving you,
Made in China?
I'm giving you writing utensils to serve the purpose of everything you do is with the purpose, right? Just understand the risk. Okay, so what do you see on that form? I got some customer information so I can record it, but what I'm going to log throughout is what actions do I have to take, what do I have to replace, what do I have to repair, and then there's a vendor column, who do I need to help me repair it, and then we start talking pricing, you know, how much does it cost, how much labor does it take, where's that labor group, shop, field, regular time, overtime. We're estimating actions in the future, forecasting what's to come. So when we get into a teardown report here in a minute, we'll discuss this a little more. So we've got some other people that look at the teardown report, right? It's useful when we go to put the pump back together. Y'all probably know that. You got to see what it looked like when it came in. Shipping and receiving, if you're missing any parts going out, that's the point where we can compare it. Let's go back and look at the teardown, look at the photos, make sure we send out what we got. Sales may review it. If they're discussing a problem a customer's having, they could go back in, look at the teardown and see what we did, what we needed to do, maybe scope. You know, maybe they're discussing, well, you can skip the wear rings, they're marginal, or, you know, other scope type decisions. And then quality. If we screw it up or if we make a mistake in the repair, it's important to know why we made a decision to perform that action, and the teardown report captures it. It tells us the most about any customer-owned material that comes in more than any other document. How do I document my findings? That's, of course, why we're here, what we're talking about. It's done on this document called the Vertical Turbine Teardown Report. This report is located in QMS. It's a controlled form. If you don't know how to get it, you probably want to figure that out. So QMS operations, you can go to the portal and get there. There's a subfolder called Forms, and you can drill down to a vertical turbine folder. Assembly checklist, teardown, receiving, those type forms are all in this folder. This is your go-to area for template forms. And so commonly these are provided to you in a traveler. That way it's already in paper and you can just write on it and go. And they're customized. This is an Excel document that is custom to the pump to some degree. I can't make a form that captures every potential configuration of a pump. I can't. The form doesn't handle below grade. It doesn't handle oil lube or freshwater injection. There's so many configurations of just vertical turbine pumps. eventually we got to the point where we said this form's good enough, we gotta start using it. And so there's some caveats there, and what that means is you still have to communicate it to the project manager, but I don't have a blank on a form to communicate it with, so I have to kick out and make a note, right? So understand that as you're going. How it works, you open the file, you input the data of stages, line shafts, and columns, and it updates all the subsequent tabs. You can print and go use it in paper format, or that file automatically saves at some point. I'll show you. And then you can use it electronically. We can upload that document after it's saved to ECM, and you can just fill it out electronically. That's ideally the goal of where we get. I understand we're not there now, so let's keep chugging along in paper format. So what the document does, it goes through these steps. I'm going really fast. I know, slow down if you need me to. These are really the pages. You got data on the front with some measurements that are requested, and then you inspect the components of the pump. You take some critical measurements on the registers and in the stuffing box. That's kind of the format. I was going to throw out this thought with you. Does that format work with how you work? You know what I'm saying there? Shane, you're nodding your head. You agree? Does that work?
Like you tear it down in that order, is that what you're saying?
you start,
So here's the question.
you wanna start from the bottom up.
Well, hold on.
That's how,
Do we start by taking off the head and then the columns?
we do.
So when we look at this, one of the first sheets we get is a bowl inspection. Should one of the first sheets we have be the head?
Usually what you wanna do is tear it down first.
Tear the whole
because
thing
if you
down
go
and then
through,
you inspect.
if you go through with the head and everything, to me, it's more time consuming.
Okay.
Let me tell you why it's in that order. That's how we estimate. We always think, and Clinton Tabor taught this to everybody he taught, you look at a plane, call it the sole plate, and you visualize that pump going in the hole. And that way you can account for all the pieces throughout the assembly in terms of your estimating. That way you don't forget a part. You start with the tail and you go to the end, go to the motor at the top. It's how we visualize in estimating terms. So flip that around, right? We want your document to support the estimator in his project management duties. So that's why it's organized the way it is.
But when we build the pump, that's where we start from the bottom up, so, I mean, it's good. That's what.
We're just gonna throw that out there because it's an easy swap. If you want the head, if you want to go motor, head, column, shafts, bolt, that's an easy rearrangement to make.
We want the document to work for those who are using it most.
We'll tear the whole pump apart, and then you start taking measurements.
Okay. So I had 24 hours to prepare this. Obviously, I intended to put something on this slide that was different than the last slide, but I don't know what it was. So, let's kick out. Any other questions there about that document? Oh, probably on the back side. Okay. Once we get that done, what are we doing with it? Uploading to ECM, right? Scanning, uploading. Yeah, can I trade seats with you, Sam?
I can move. I don't mind moving.
Okay, so, let's get to it. So how did this start? Well, I guess the story I heard is we used to just write notes on pumps as we were tearing down. Then one night in a hotel in Louisiana, Granger was going to a third-party shop, and he said, well, I gotta have a form for how to inspect this. So he went and created this template. And
They've changed a lot over the years.
And it's morphed several times. I was going to show you what an old one looked like, because you probably want to know where we came from to understand why it is the way it is now. So this is the document. I need the keyboard. I can't work it. And so we had info above, and you'd capture some of these nameplate things, and then you'd start on your teardown. So went bowl components, line shaft. Doesn't that look kind of messy? We've cleaned it up a little bit, and H just kept copying this over and over, right, H?
Uh-huh.
And you get all the way through. What this one had that these days we don't, or the enclosing tubes, the whole oil assemblies, components. We don't see many oil lube pumps anymore, do we? Some, but not many. It doesn't, for me, it hadn't justified fixing the form yet. That's a note, Sam. oil lube pumps. Packing survey, right? That looks the same. That document hadn't changed.
Yep. Then we used to have to draw stuff out.
You used to have to sketch the pump, how it looked. We've tried to make that easier on us now, so, and still capture the same measurements. So that's where we came from. That's what it used to look like. Here's what it looks like now. This is what you get in your Traveler, right? This is our joke. We always call it City of Many Pumps. And so when you put the names, city of whatever, City of Waco, City of whatever, and give it a project number, that Excel document automatically saves, because we don't want you saving over our template. So you give those two things immediately to start in this document, and it'll save, if you're ever in the Excel version. And so this is what it should look like when it gets to you in the teardown. So what's the first thing I'm doing on this? How do you approach it? What does everybody think?
Ginger, what's your name, buddy?
Asa.
I'm a big fan of having names first thing, and the byline.
Usually what I do is just get the voter information.
I mean, if they put their name, you're gonna know who it is.
So put your name on it. That's critical. And let me tell you why. This isn't being graded, whatever. That's not why. It's so if your audience, right? If your audience has any questions about it, they know who to go to ask those questions. Rather than me walking around the shop saying, Shane, do you know who tore down that pump for Waco? Asa, you know who tore down that pump for Waco? Oh, no, I can't really remember. I wasn't here that day. Well, you know, I'd get right to the person and can ask that question.
Preferably putting first and last name helps, just from an ISO standpoint. I know there's not like a whole bunch of ACEs.
If there's two of you, put both your names up there.
Yeah, both names. I mean, whoever's doing the teardown,
Put
be
both
on there.
names.
The two references there.
So here's where I was talking about stages, columns, line shafts. You put those in here, and then these rows will become visible. It's programming in the Excel document to show and hide. And so trying to populate a form, because this old form we had just had 12 rows, and it wasn't tailored to the pump, and you'd end up with extra pages or not enough pages. So those type items become visible and gives you a spot to fill out the necessary information. That's what the whole form should look like when it gets to you.
If it doesn't look like that, ask somebody for help. It doesn't take me 5 minutes to put this thing together.
So that's the form.
Because we got in trouble one time on that cover page where one of the PMs put the wrong, not one of the PMs, the head sales guy put the wrong job number or something on it.
So all that's doing, if Jason has to go open it, oh my gosh, he's popping into our portal and he's typing in VTP teardown report. Y'all seen this page, right? That should be the home page. he's asking it for that document, and it should give him an Excel document that works. Maybe I named it wrong. You know, I swear.
You need Jason to do it for you.
No.
I'll Teardown report.
Why would we put it comma VTP?
And they're all consistent.
Operations forms. I'm just gonna go over
I
this
just go to
again.
forms and,
Don't click too fast, wait on it. Pump shop forms, VTP, and then he's opening the vertical turbine. There's a submersible turbine teardown that's relevant, assembly checklist, whatever. So,
if you have a special pump and you need extra pages, this is the time to holler at me and say, hey man, I don't have a place to annotate this. I can get you the space. I can get you anything you want just about on this thing. But only if you ask me. I can't read your mind, you know what I mean?
there's what the document looks like. I can change the number of line shafts to 3 or let's say stages to 12, and that page,
Take it a second.
if macros are enabled, will auto-populate.
There you go.
It's some homemade programming, but it works. Shane Wallace and I made it, yes. Yep. I give credit to Shane. He did
I
most
think
of
it goes up to 20. Didn't me and you have 20? Joseph on the last one?
Yeah.
I think it goes up to 20 shafts and columns.
So,
And then you gotta make this whole new teardown report.
Then I gotta start customizing it.
so I just thought I'd write on here because we ask for notes from you all the time. That helps us communicate. I thought I'd take one and just write some notes, kind of an example here, the City of Mini Pumps job, and we can use it as conversation as we go. About halfway through the hour, so
Did I say so?
yeah, sure.
On here, this is a lot of the newer guys, they should know by now, but that bowl stick up on that pump, that's important. We need that on every pump. That's not just the stick down on the head, that bowl stick up. That'll tell you when you got that bowl together, if you're together right or not at the end. On the bowl.
Now, when you say the stick up, on the project management side, we have two. We have a min and a max. So we take that, look at that bowl, and it's when it's stabbed all the way down, and then when it's pulled all the way up. So we record both, because then we also have a lateral.
Yeah. And if the bowl's locked up, you still want to get that measurement. You're just going to note that the bowl's locked up and has no lateral.
Everybody know the difference between stick up and stick down? Does that need defining?
Let's define it just in case.
So it's all about a distance measured from a flange, from a mating surface. So a stick up would be, really it's towards the driver from that mating flange, or at any point if the shaft is recessed from that mating flange, it's a stick down. If it protrudes out past that mating surface, it's a stick up. Is that too technical? Then that makes sense?
Flange up, stick up. Flange down, stick down.
There we go. So there's a definition of a stick down right there. Motor shaft stick down. I'll tell you, there aren't places for every necessary dimension on this form. I made some notes. We can add things.
I would really like if we could add the bowl stick up on there, just so it's not forgotten, because it gets forgot a
That
lot.
would be very
And,
helpful. I didn't.
Bolt
And-
stick up. Okay.
bowl stick up, because
Let me tell you.
it bites us in the butt.
So, I didn't scan my assembly because it was a larger page. So let me tell you where the intention was in our document. We intended stick down to be recorded here. You could just make a note right there.
Yeah.
and bowl stick up to be recorded here, from that plane. Now, I agree it would be much more beneficial. Let's just capture it in a blank on that front cover page with other critical dimensions. That way it's visible.
And then they can write it down on that other
Well,
page
what's the
too.
other one, the house already torn down completely, by the time you make it back there?
Yeah, we want, you know,
You won't be able to get it.
this is your first page, you can start filling out the information and take the pump apart, and you can get that stick down, and then you're moving to the next page after the bolts are disassembled.
So you got 3 measurements. So bowl's locked up. Can't tell if it's a min or max. Jason, what would you like to see? What do we call it? If we got to give you 1 dimension because I can't get 2.
I'd like you to call me down to the floor so I can look at it and decide.
So
We could determine if it's locked.
I'd just say locked up and call it a min or call it a max, one or the other.
You
Doesn't
can look
matter.
at that bottom ring and see if it's all the way down or not.
You can
The
measure,
only reason this
you can
number
measure
becomes real important is because I gotta get it back together.
Yes, that's why it is real important.
So if it's stuck somewhere, I need to figure out how I can jerry-rig it. You're gonna have to take it further apart. You have to say it's stuck, but then we have to consider, okay, let's take off the first case and let's see if it unsticks. And then we get a measurement, and then I can back a map into it. I can always back it into it, but if it's all the way apart by the time you tell me, I don't have anywhere to start from. So long as I have a place to start, I can always do the math to where I need to be. But you've got to give me a place to start. You got to give me the end of the shaft to the first face that you can get to on an impeller. There has to be somewhere that I can recognize as a marking point, somewhere that I can base all the other measurements off of.
You can also measure from the bottom wear ring that gap.
See if it has a gap or not, if it's moved, but it could be
There's a
stuck
few
in the
different
middle.
places
yeah.
you can go for, but
Would you like to explain what the importance of the stick is?
no, let's get through this. Let's get through this first, and then we can explain some of the more detailed ones as they come. We can ask the questions.
So on the Excel document, this is called the nameplate sheet. Here's what you're really doing, capturing the nameplate info. If you've got a piece of info that there's not a blank for, write it. You don't have to stay in the lines. So write whatever relevant information you think. Nobody's ever going to say, why'd you write that note? Because it may be useful to somebody or you at the assembly. So keep your audience in mind, primary, PM, and secondary, the assembler. So
Don't leave it blank, because if you leave it blank, I think that you just haven't done it. Put not applicable or unreadable or,
maybe they didn't have a horsepower on the tag. That's common.
yeah.
Maybe they didn't have a speed or a flow rate or something,
You put NA at that point.
or dash. Yeah.
Or you put unreadable in something. Give me some indication that you've at least reviewed.
Pump make, Flowserve, Fairbanks, Goulds, those are common. There'll be others. If you don't have a tag, let's write no tag. Write that right then and there. If you don't know the serial number or model, if you don't have a tag, you won't have that info. So that's where NA or no tag is a good communicator. Flow rate, typically gallons per minute, head and feet. If not, just strike through that, write PSI or MGD, whatever units you have, communicate it that way. Because there may be somebody in sales that takes this and doesn't understand that a 40-inch bowl makes a lot more than 40 gallons per minute. So it's a communication factor that it could be 40 MGD or whatever. So, or PSI is probably a better one. Feet to PSI is a more comparable conversion. So most of that is on the tag. If you don't know, write NA or unknown. Lubrication. What do we mean lubrication? Everybody know?
What lubricates the shaft?
What lubricates the line shaft bearings? Product is the fluid the pump makes. You should write product in there unless it's something else. That's 90% of what you see The other one is oil, and you can tell an oil pretty quick. You'll know there's a lot of oil, but in closing tube and tension assembly almost always defines an oil lube pump. There are other pumps that we rarely see where they push positive pressure fresh water, clean, non-potable water down that tube to lubricate the shaft.
Don't they do that in TRWD?
Yeah. Yeah. So there's some freshwater injection. If that's the case, write that down.
It may even be a grease, even rarer one, but we've seen one recently.
Discharge, the intention here is above grade or below grade. And if you're in the Excel document, these are drop downs. But that's how the form comes to you. I wanted you to see, because you can't just drop down and pick those fields. So motor type, hollow shaft, solid shaft. That tells us so much about the assembly. And then, did we receive the motor? Maybe it's in the warehouse and it needs action taken. The PM has to coordinate delivery. That's an important delineation. Or if we didn't get it, sometimes the customer will argue with us, oh yeah, I sent the motor. We don't want to end up in a debate about it. Log it how it came in. And this is a second catch too, because we got an assembly or a as received checklist. Basket received. We added this because we were losing baskets all the time. We're sending pumps out and the guy would say, I didn't get a basket. Then we'd have to go back and get it. So write yes or no if I got it. Maybe it's on the assembly, maybe it's loose. Typically it's probably loose, right? Base to bell. Everybody knows base to bell, right? That's the pump length that we commonly refer to. It's not a shipping length. It's basically the reason base to bell isn't important is because it's the distance from the mounting surface, and if that water level ever drops below that base or below that bell, the pump's not going to operate. That's why it's an important dimension, because you have to flood that bottom impeller. Really, it needs to be higher than the bell to function properly. But that dimension is the industry standard for pump length. And then bowl length. This bowl length is from that mating surface with the column right there down to the bell. Don't measure it to the tail bearing. Don't measure it to the end of the shaft or anything like that. The reason this dimension is critical, if we re-bowling, say we get a Fairbanks Morris pump in and I sell them a flow serve bowl assembly, I have to evaluate whether my length is going to change that base to bell. If the flow serve's longer, then I got a problem. If the flow serve's shorter, I may still have a problem. That length is critical. It helps us define whether we can replace the pump or not if necessary. Top shaft stick down, bowl stick up, we talked about. Okay, in this receiving notes area, there's so many just random thoughts and observations we can't capture in fields. So let's talk about each one of these. Visual observations. What do you see when it arrives? What's it look like? Shane, we had a weird one that was Marble Falls. I think you tore that down. Suction was plugged with mud. You get something that's just obvious before you start knocking into it, write it down. Ideally, pictures capture that, but it doesn't hurt to write it down. Loose parts. We spend a lot of time looking for items or questioning the same Marble Falls pump. I was trying to determine if we had a sole plate or not. I don't know. And the whole answer was we didn't. We never got one. There wasn't one ever. No, there never was one. So I come down and I ask, and we say, well, we think we set it on the side. Now I'm looking for this missing sole plate that doesn't exist.
Yeah.
So the whole thing is, what did we get? Because we need to send out what we got. It needs to match apples to apples. Missing parts, what if we don't get a motor shaft, or some other critical component? CRMWD, they just send us bowls recently, right? We're missing columns, heads, whatever. So log the reason for you not inspecting those parts on that form. No head received. These type notes, it's great to have it in one place. If I put the motor shaft up after my teardown or during my teardown, I put it on the shaft rack, tell the assembler that. Loose parts are in the bucket inside or put outside or in the impeller rack, whatever. Impellers in the rack, impellers on the hill. Y'all probably don't even call it the hill anymore, do you? All types of notes. I guess it's still uphill. And then exceptions. What if the pump's below grade? Well, it's this was a below grade. My teardown report didn't really match. Things like that. Those type comments. I can't define all special features, but you'll know it when you see it and make note of it. So this is a common one. Where's that head shaft assembly? Where's the mechanical seal if it had it? I've gone out to look at a packing survey and found out that the pump had a mechanical seal. And you say, well, why did we do a packing survey?
Well, because we don't know, because if they're thinking about changing over.
Yeah.
Or they change over from packing to seal.
But it's got to be communicated there's a seal.
Yeah.
Typically that means project manager, you got to estimate for a recondition or replacement of the mechanical seal.
On that head shaft, on that motor shaft, if you're in the field, don't bring back a shaft without the give key and the nut.
Yeah, because it's...
The give key and the nut needs to come with that motor.
So if we're making a new shaft...
Let's be consistent too. What do we want to do? Do we want to leave it in the field or do we want to bring it here?
Bring it here.
Everybody understand that?
Because if you don't bring it here,
the field monster eats it. We get back out to the job.
Well, we're looking for it here in the shop. Did it get brought back to the shop? Did it get left there? We don't know. We're guessing.
Yep. Bring it here. Okay. So here we jump in the actual inspections. At this point, you've already torn it down, right? Pumps apart, and now we're starting to take measurements. So this is the inspection part. What I would say is we want to get a photo of every component that you tell us there's action necessary on. Because I'm having to communicate that to that customer. Hey, we need to replace 3 bearings on this pump. And he's going to say to me, why do I need to replace the bearings? Well, your clearances are bad. I can tell him on this one. But maybe it's always good to have a photo. Let me say it that way. Hey, look at the grooving on the bearings. Look at the wear on the shaft or the thinness of the impellers, whatever it is. Look at this condition. So just a note that I was thinking about preparing this. Take photos when you say to replace something or take repair action. So what I would do is in this inspection, I'd start by filling out the easy stuff. I always get the easy stuff right off the bat. You can tell if the bearing's bronze or plastic or rubber or whatever, right? So saying that material, I'd do that right off the bat. What if it's a material you don't know? Like a Teardown or a Vesconite or something you can't tell by looking at it. What do you do there? We run across that? Okay, I'm just dreaming.
It's been a while since we've done any of them. It's been years.
No, hell, Trent just had one that had Vesconite bearings in it.
Well, I guessed it was Vesconite, yeah. It's plastic, self-lubricating.
So you got amber colored plastic on the shaft back there in that that's gonna,
That's Teardown.
oh, that's stored on?
Why don't you pull that out? Yeah, let's just pull that out. That'll be a good discussion point. Right behind you, CJ, there's a shaft and a bearing. So this is a 4-letter word at Smith Pump. H is laugh. Yeah. We don't do Teardown bearings because of this job. So this is North Texas MWD diversion pump station. Bearing looked like that. That's Teardown. It's presented to us as self-lubricating.
We go back with bronze normally, don't we?
Well, you can't use bronze. This is like a rubber. This is a line shaft bearing.
Oh, okay.
And so this is supposed to lubricate it. The problem is it trapped in the debris and that just started eating up the shaft. But that's a case study. I'd write my material, I'd measure my length and measure my OD and understand we're just looking for fractional readouts, especially if it's bronze, because my audience is just going to estimate bronze that's going to be oversized anyway. So put a tape on it and give us 2 3/4 or 2 7/8. I don't need it down to a 32nd or a 1,000th of an inch on the OD and length. I do need the ID to a 1,000th of an inch. That's my pass-fail criteria for replacement. So right here I'm writing, and this is a sample teardown. You've got your inspection form out, right? So based on that, what's the PM going to do? He's going to say replace 3 series case bearings. And what's he got to know? He's got to know what size bronze to buy. Make sense? Write it down. I didn't use pen and paper for no reason.
I'm gonna replace it with 3-inch OD,
Recline.
1 3/4 ID.
Yeah. And how long do we need? You got 3 pieces that are 3.5 inches, right?
Plus you gotta give Junior something to hold on to.
Man, why you give away all my talking points?
I'll be quiet, I'm sorry.
Since when?
Okay, so yeah, you got to account for material to check up on and distance apart, length apart. So that's what the project manager is going to do. And then he'll go pick up the phone and call the bearing supplier. Or if you're like me, you just guess at the price.
We have a sheet for that. I know what the price per pound.
So you're allowed to guess, but we're not.
Exactly.
So bronze cost, no, this isn't a guess. This isn't a flat out swag guess.
Okay, you have.
Bronze costs about $5 a pound and weighs about 0.25 pounds per cubic inch. Now pull out my calculator and calculate the volume of bronze needed and multiply it times the rate, and I get you a price.
I have a cut price and a box price.
So it's not a guess.
And I don't have to talk to that sales guy that wants to do that.
It's not a guess.
We've calculated the weight and we know the cost.
It's still a guess because I don't know that I can really get that size bronze for that price. Yeah.
We're close.
So other topics of conversation there. How do we know reuse or replace? This is important. And let me say it this way, because your audience, the project manager, is stupid sometimes. Sometimes they're just going to regurgitate what you tell them. And so rather than question what you're telling them, they're just going to go price and quote it that way. So if you say reuse them all or replace them all, they're just going to do what you tell them to. So we're relying on you to communicate what that distinction is. So how do you know what to say there? That's not a whole lot of confidence out of the group. I mean, this is why we're having a conversation today, really.
Got our standard. Bearing clearances.
So bearing clearance defines it, right? If this ID is greater than this OD, what's that bearing do? That ain't good. Right, H? What's that pump sound like? That pump was rough. Shaking a quarter mile.
If we're going by clean, technically, that suction would be replaced too, because it's over what we would make it to.
I put that right on the boundary. So and we'll talk about this. Any other reasons you might reuse or replace before we go into the clearance discussion? What if that ID looked like that?
Yeah.
And the reason is you've decreased the bearing area. The area that load pushes on is decreased by a considerable factor, and the shaft is applying pressure on the bearing. When area decreases, force increases. And so then that friction component's going to be greater, and it's going to wear at a faster rate. It's probably way more technical than you need to know, but just understand if it's grooved, that's the delineation we use. If it's grooved, replace it. One-sided wear on the bearing, that's the shaft. You can see it in the bearing, and so you should check that ID at 0 and 90, right?
Yeah.
Flip it, make sure they're close, and if not, you could say one-sided wear or something. There's really not a lot of fields for conditional type observations. I'd write it out here. Replace for clearance, replace because grooved, whatever.
Now, what's the clearance or the tolerance for the one-sided? Like measure here and measure here.
If it's within reusable clearance, I'm going to reuse it, whether it's one-sided or not. The problem is if at any diameter that clearance exceeds our tolerance, then and the tolerance is pretty tight. We're talking about 10 to 15 thousandths. We'll get there. Then we're going to say replace. So let's have this clearance discussion. And so I got to get to the form, and I always just search. So I don't know where anything is. I always just search for it, and I never find it. So this document, these are machining tolerances. This defines what's acceptable by Smith pump standards. It's in our QMS. Looks like somewhere in here. So we don't want to float a lot of copies of this around. There's a reason why you don't have it at your station.
No, I did have that one station still sent to you.
Because if we change something on this document, the documents that you have, the copy you have, is no longer accurate. I'm running out of time, guys, so we're going to finish the clearance discussion, and then we're going to break. We'll have to continue this on. I can't cover this whole topic in an hour.
Well, what about putting that in every teardown, so that way if it does change, it keeps moving?
I don't mind having, say, 3 laminated copies out there.
We only need 2, one for me and one for Brad.
Yeah, I mean,
I disagree. We need it on the floor too.
I gave Shane one. I gave Shane one.
So this is pretty easy. I mean, this isn't hard, and you'll see when I pull it up, because I can remember the clearances that are allowable. I just always forget what that threshold is. So this document goes through wear rings. What if I have stainless wear rings? All types of standards for us. And then you get down to 1, 2, where we have bearing to shaft clearances. So for different size shafts, we may allow different clearances. I've never seen a 3/4 inch shaft. I don't know why that's on there. And you have a little pencil. And so here, this is the bulk of it, is 10 to 12. These are our machining tolerances. And then at 2 7/16, you get a little bigger, you want to allow for a little more clearance to lubricate that area. And so you go 11 to 13. What if I've got a 5-inch or 6-inch shaft? What do we do?
About 14 on those.
We may allow a little greater. Technically, our tolerance says we want 11 to 13 on
5 to 6.
On anything above 4-inch. We just want to keep it between 11 and 13. So here's the conversation on repairs. This line gets it. In general, on repairs, bearing clearance should be restored when the diametrical clearance is 150% of that minimum. What the hell does that mean?
Time and a half, buddy.
1.5 times this minimum column. This is easy, right? It's 10. What's 1.5 times 10? 15, right? Yes. So 15, maybe, I guess that's 15 and a half. 15 to 16 is the max end for those allowable clearances before we recommend they be restored. Now that clearance is not, that's to the shaft. So if that shaft is going to be worn 1,000th or 2, and we're still going to reuse it, then that's taken away from that top end of your allowable clearance. The whole thing is we want to restrict the freedom of that shaft to move radially. And if you can do that, then that pump's going to run smooth. This is the whole reason for that tolerance. So if you're at 15 and it looks like this, I'm going to say replace it. If you're at, what's my clearance on my example, Junior? You said I needed to replace this 1.951.
You're at 13 and a half.
I've said to replace the shaft, so I'm going to end up at 1.938 or 1.9375. I just go to 1,000th, 938.
Yeah.
So I'm at 13 thousandths already.
So we're good.
You're within our tolerance as long as that surface roughness is smooth. If you can put your finger in it and don't feel any gradient or any roughness, then it's probably good to reuse. The whole thought there is you're going to charge the customer so much money to replace the bearing when it's been running for 10 years and only has 2 or 3 thousandths wear. It's just silly to replace that when there's no forces exciting on that bearing to create wear.
Well, years and years and years ago, things have changed now, but you know, it used to you have one bearing that's overclamped, redo the whole pump.
Yeah. This costs a lot of money. So
yeah,
we talked about price of material. The estimator is going to say for each one of these bearings, he's going to factor in material cost, cut charge, freight, and then he's going to look at quantity of hours to go find the part in the warehouse, bring it to the machine shop, chuck it up in the machine, finish out ID, OD, cut to length, press the bearing in, remove the old bearing. All these type actions have to go into his estimate. I usually just say 3 hours of bearing, you know, and so 9 hours at $80, that's $720. I'd guess $125 in material costs, a couple bucks for cut, and $20 for freight. Y'all really aren't good at following along on your estimate sheet. So for those 3 bearings on that 1 15/16 shafts, we're talking about a price that's $1,100. And the guy's saying, well, you just send it for preventative maintenance. Your wear's not bad. So you're charging a considerable rate. We have to communicate why. You know, look, if you don't replace this, it's gonna accelerate wear, and you're gonna have a problem within a specific time frame.
You can normally see on the bronze if it's got the wear I mean, it's normally visible.
Any questions there? I mean, here's the thing. Don't ever condition what you're telling the project manager based on cost. It's how we make money, one, but it's how we make quality repairs. And so if you see something that doesn't meet tolerance for surface finish or clearance, let's say to replace. And then it's up to the project manager to estimate sales to communicate why and go get the order. And so that's the whole point and that measurement there. Port body, everybody knows what a port body is. May call it a discharge case. Port body technically has ports in the side of it to alleviate, they allow some blowout of pressure. And they'll have plugs in it if it's product lube. That you always kind of want to consider that, right? Product lube has plugs, oil lube, those ports are open. And so that port body almost always has a bearing. If it's an oil lube pump, it almost always has two bearings. That bottom one throttles the pressure, the top one throttles it further, and the flow wants to go through the path of least resistance, which is out the ports. So you almost always have two bearings there, hence the call on to check double bearings.
They're two different sizes. Go ahead and make a note. Drop down. Give me some more information.
Tube connector bearing, we know what a tube connector is, right? Typically that's oil lube pumps. And what does a tube connector bearing have? You got threads on the OD to connect to the tube. I don't care if it doesn't have a tube on it, it's still called a tube connector bearing. Those are typically screwed into the top of that discharge case, more commonly on your bigger pumps, and they adapt to that tube so you create a seal between the oil and the product. If it's most commonly not applicable, but we wanted to give a blank for it, so write in A there for reuse and fill in all the blanks is an ISO requirement. I don't know where my cursor is, but instead of giving an ID OD on something that doesn't exist, just you can always draw a line. I wanted to show you all that. If I got bronze all the way down, don't take the time to write bronze all the way down. I'm cool. Jason's probably cool with this. Just draw a line with it. Sam may be the only one that has a problem, but I don't give a damn.
I don't have a problem with that.
As long as on the bowl, like, you know, you got the measurement of the length, you know, the rest are 3.5, that's fine. So I see people just measure one and go,
yeah.
Put them all.
Even in cases, don't assume they're all the same length.
Yeah.
I'm not saying skip the measurement. I'm saying
verify.
Get the writing or the recording of the measurement if it's the same. I can finish bowl shafts real quick. Here's this tolerance right here. We allow diametrical wear. Where the heck is that form? It's within the tolerance of pump shaft quality. So PSQ says 0 to a minus for this size, 0.03. If that shaft has 1,000th wear on it, I'm not going to tell the customer to replace it. If it was 3,000ths, then that's starting to take away from the clearance on a new bearing. So that, I rule of thumb, I was thinking 2. I was going to pull this up and look, but
It seems a lot for 3 to 4.
that's PSQ. That's the standard there. So I just, we record the dimension here, and if that's worn more than 2,000ths, I'd say you have to take action on that journal. Other reasons for replacing the shaft, if it's broken, duh. If it's grooved at the bearing journals, if it's pitted significantly, you know what pit is, right? A little hole, a divot in the surface, it's corrosion. If you've got one-sided wear, if it's bent, things like that. We want to put all those in that condition there. And that will lead towards this determination to reuse, replace. So, right, conditions at each journal, diameters, conditions at the journal, and then actions. 99% of the time, the action is just going to be none or replace and draw a line down. If you've got a shaft like Tarrant, where you've got a 6-inch diameter, that material costs $15,000 and then labor on it to cut it, it becomes cost effective to build the journals back up and replate. So like I would just leave that up to the project manager to make that determination. That was our whole intention with the action column, but I wouldn't think y'all ever tell the project manager to repair a journal. Other notes could be captured down here. You'd want to say where it's pitted at. If it was just, y'all seen those carbon steel shafts, how they come in, you just corroded down the whole length. If you've got heavy wear or whatever, here's where I'd make the note of where it's turned down to what diameter, and if you've got bronze transferred onto the shaft, other type, just observations. I can't capture them all. I can't even verbalize them all to you in this short meeting. So makes sense. Anybody got questions on the shaft?
Here's a good rule of thumb when you're looking at these shafts. When you're looking at any piece on this thing, how would you go about rebuilding it? How would you go about making me another one? If you need to just draw a quick sketch and say, hey, you got this much thread, this much turn down, this much length after that, followed by another thread, just draw it out, because at the end of the day, what's going to happen is if it's determined that it needs to be replaced, somebody's got to make it. So give me enough information, what you think you would need to duplicate the damn thing. Tell me, hey, this is what we need. If we took this shaft and we threw it in the garbage right now and all you had was what I had in this paper, what information does Junior or Bradley need in order to remake the damn thing?
We want the old shaft.
Ideally. But you don't always get that option. What if it's broke?
Sometimes it does appear.
Yeah, it gets cut, it's broke. So give us the information we need.
Accurate.
Look at it as though you had to remake the thing. That's the trick here.
Okay, any questions? Y'all good with that? Okay, I didn't want to overwhelm you. I can keep going, but I just thought we'd focus on bearings and shafts right there, and that way we can retain some of it. So again, let me circle back to the expectation here. This is our bread and butter. We should exceed everybody in the market at doing vertical turbine teardowns and repairs. We want to be really good at this. This is why we're taking the time to do it. So practice it, ask questions. You got a wealth of knowledge around you with project managers, operations staff, and peers that have been through it before. Know that, use us, and let's do a good job at this. And in the end, then we become more efficient. Project managers don't spend so much time asking questions and quoting, and we do a better job to service the product, and people come back to us, and we get more business. That's the goal. So thanks everybody. I'll wrap it up at that if there's nothing else, and look for part 2 on this. Maybe I can go faster once I get out past that nameplate type discussion. Cool. All right.
The clearance thing.
Yeah, I will,
I mean, me and Bradley know, but I'll
I'll
like
make
to have
3
it.
of the machine tolerance work instructions and laminate it. If y'all have other copies floating around when I do that, I need those to be trashed.
Thanks, Trent. Probably
As long as you know she
appreciate
has 3.
that.
Hey, you did a good job holding it down.
Knows how many kids go through life.
Right. yeah, if